Welcome back. So Exponential Transformations. I did an introductory Exponential Transformations video. I'll put up a link up above there, and I mentioned there that I'm going to do a few examples just to illustrate the concepts of trying to transform and also getting some kind of an idea from examples, what we should think about these stretches and compressions, reflections in the x or in the y when it is an exponential function. So ultimately, so what I want to do here is first let's identify what the parent function would have been. For instance, for this, so for instance our parent function f of x is equal to, so that is always some kind of a base raised to the x. In this case, notice that our base is 2, so we have our parent function as simply 2 to the x. And now that 2 to the x is being transformed to this g of x right here, and we want to figure out what the actual transformations were. Now, for our transformations, what we have is that our g of x transforms our f of x in some way. So we'll have some a, and then it's going to multiply our original parent function f. Our input is being changed to some d, and then in brackets x minus h. And then we're going to have some kind of a translation plus some k. So our goal here is to identify what is a, what is d, what is this h, and then what is this k. And then we can actually see what that would have done to the function itself, all right, in terms of the transformation. And I'm going to speak of it, and then I'm going to graph it for you on decimals so that we can see, okay, did that actually happen? Okay, so first off, I'm going to simplify this thing. So let me take it, so this right here, and let me maybe copy it. I'm going to paste it down in here, and I'm going to simplify it in some way because I want to be able to identify these a's and d's and so on. So first of all, well, my a is rather easy to identify because I have a 3 in front. Now I have 2, and then the exponent itself, negative x plus 1. So I'm going to take out the negative. So notice that you do have to be careful here in the exponent, because you don't want to say that d is actually negative 1 there. Okay, now it will be, but what it will do is it's going to so when you factor it out, it's going to change, your h. So notice this is what we're going to have, and then minus our 1. So here is our a, here is our d, which is negative 1, here's our h, and then here is our k. So what we have is we basically have the following. Our g of x is equal to 3, so that's right here. So 3 f, my d is negative 1, then it's h minus 1, and then that is minus 1. That's what we have done to our original parent function. So what does this mean? Well, what this will mean is that this 3 is going to stretch, in the y direction, my 2 to the x. So it's going to stretch it in this way. So it's going to stretch it out, in this particular way. It's going to try to pull it apart. So that's the first thing that we will see. Now, your d, which is negative 1, so the negative means that we're going to have a reflection in the y-axis, so it's going to reflect it back. So that's one thing we're going to see. There is no stretching or compressing because the magnitude is 1. All right, so there's no stretching or compression in the x because it's just 1. This, so our h tells us that our parent function is going to move. All right, so it's going to move one spot over, that direction, and then this, which is our k, is going to shift it down 1, which means our asymptote is also going to change around here as well. So let's see that happening. So I'm going to set that up in decimals, and then we're going to input the actual values. All right, so welcome in back. So you see decimals there, and then our actual function there as well. So I'm going to try to just concentrate, okay, on this one right there for us. So what do we have? We have our A is 3. So what did we say? That should, okay, stretch it, right? So it did. It pulled it this way, this direction. So that's the first thing. Our D is -1. Okay, so what that should do is that should do a reflection in the Y. And notice that's exactly what happens. It flips over, okay, in the Y. Now my H, okay, so this particular H was equal to 1, okay, and notice, so if I go back here, 0, okay, and now notice 1, which is shift 1 spot in this direction, and then my K that I had, we had our K, which was equal to -1. I'm going to put -1 in here, which brings it down. All right? And that's exactly what has happened. So that's the transformations that we had. So that's one example that we have. Let's take a look at another example that I've prepared for you. And then we're going to try to break it down once again in terms of these transformations. So this example, what do we have? So I'm just going to break it down. So again, what I want is I want to find out my g of x, okay, so is equal to a, f of, and then d. So I want to put it into this form. So first off, what is my original f of x? Okay, so what is my parent of this? The only thing you're looking for is the exponent, right? And the base. So, well, we have our exponent within here, and then our base is 5. So it looks like our parent function is 5 to the x. That's what this is. And now we want to be able to identify my a, d, h, and k. So let's do that. So if I take this, I'm going to copy it, I'm going to duplicate it. Okay, so bring it down. And now let's work it out, okay, and simplify it. So it looks like we have 2, so it's in front of those brackets, so it's going to be 2 times, and now I have 5. Now in the exponent right here, so I'm going to take out the 3 which you see in the denominator of the x. So this is a little tricky. So this is where your math skills come into play. So notice if I take out, okay, the 3, so I'm taking that out, that's going to leave me an x, and it's going to change. So notice your 2 is not going to be a 2, it's going to be a 6, okay, like so. Because if you distribute this back inside, what would you get is you would get 1 over 3x plus then 6 times 1 over 3, which is 2, which indeed is equal to x over 3 plus 2 originally. All right? So that's what we have here in the denominator. So this is 1 over 3 x plus 6, and now the k is just -5. So now let's identify all of these. So what is my a? My a is 2. So what will that 2 do? That means it will stretch it in the y. That's the first thing that will happen. For our d, which is right here, so that's 1 over 3. And in this case, what's going to happen is there's no reflection because it's not negative. So all it's going to do is going to kind of stretch it out, okay, in that direction in the x. So that's what you will see. Then we have a translation. So notice here, so my h, okay, so be careful there, because notice the signs change. So the h is actually -6. All right, so that's what that will be. So that's going to translate it 6 spots over in the x direction. All right, so it's going to shift it over, okay, so 6 spots, okay? And then your k, which is right here, so that is this, which is -5, which means it's going to move it down 5 spots. So let's take a look in decimals. I'm going to try to bring up decimals, f of x. So I'm going to change this. This is 5. It's going to look a little different. Now my a, we said this was, so let me change these back just so that you can see it all happening. So I'm going to zero off first, and I'm going to just do them one by one. So we said a is 2. So what should happen, okay, to this right here? It should stretch it out, okay? So that's what should happen. So 2, okay, there we have it, stretched out. Now, my d, which is 1 over 3, that I have in here, so I guess this is 0.333333 because I have to put it in as a decimal in here. So 0. Let's say 333, okay, and so on. So what would that do? Okay, that means this actually stretches it out in this direction. Okay, so that's what happens. All right, so it stretches it out in this direction. It actually does the opposite. So the x, okay, kind of pulls it apart. Okay, so that's what happens there. My h that I have, so now my h was -6. So I'm going to put this in here. So it should shift it over. So notice it just shifted it over in this direction. And then my k was -5, which brings it down. And that's what has happened here. Before I end this with the 2 examples that you have seen, is I do want to remind you, so with the a, you know, just so maybe you can have it as a reference, okay, so that you know what is happening. If you take the absolute value of a, and it is going to be greater than 1, then what that does is this results in the stretching, okay, in the y. So in the stretching in the y, that's what happens there. If your magnitude, okay, or absolute value of a is between 0 and 1, then that does the opposite. It compresses. So it compresses in the y, which means it tries to compress it in this direction. This is something that you probably will forget. I forget sometimes as well and make mistakes. I'm aware that there is stretching and compressing, and sometimes I can't remember which one it is. So this is just as a reference for you. Now, the other one also for, you know, your D that you have in terms of the compressions, this is actually the opposite. So when you have this D in your X, okay, so what happens, this compresses it in the X. So that means it compresses it this direction, which looks like it's stretching in the Y, okay, but it's compressing it in the X. And then again, if it's between 0 and 1, then this is actually stretching out. So this is stretching in the X, which means it's trying to pull it apart this way, which sometimes you might think of as compressing this way in the Y. So that's just a summary for you after those couple of examples, which hopefully will help you. You know, you can make notes for yourself on that. The translations are rather simple, you know, moving which directions, the H and the K's, that's what you can have. You know, the H actually moves it either right or left, depending if H is positive, okay, or if H is negative. Okay, if H is positive, okay, to the right, negative to the left. And then the same thing for your K in general. If it's positive, it goes up. Okay, if it's negative, it goes down. Okay, thanks for watching. I hope that this was useful. Cheers, everybody. Bye.